Okay, we're going to go over chapter 10.8, Linear Inequalities. This is for Math 0320, Intermediate Algebra. So the concepts that we're going to cover today are graphing linear inequalities, talking about the difference between set builder notation and interval notation, adding and subtracting properties of inequalities, multiplication and division properties of inequalities, inequalities of the form a less than x less than b, and applications of linear inequalities. So going over concept 1, graphing linear inequalities, we have that a linear inequality in one variable x is any inequality that can be written in the form ax plus b less than c, ax plus b less than or equal to c, ax plus b greater than c, and ax plus b greater than or equal to c. So all it did was take different types of linear inequalities with the variable x and just showed you using all the different inequality symbols. Okay. So when looking at the examples and when graphing the inequalities, we have to notice that if we see a less than or a greater than symbol, then when we are graphing this on a line graph, we are either going to be using a open dot or parentheses. Okay, that is because when we have less than or greater than, our numbers that we are going to be less than or greater than are not included in our solution. So that means for the symbols less than or equal to or greater than or equal to, we'll be using a closed dot or brackets. This tells us that the number that is in this inequality is included in the solution. Okay, so let's look at example 1. Example 1, we have x is greater than -1. So we're going to draw a number line, and the only number we're going to put on that number line is the number that we see here. So in this case, -1. So I'm going to write -1 on the number line, and then it says x is greater than -1. So all the numbers greater than -1 are going to go in the right direction. And since this is a greater than symbol and not a greater than or equal to symbol, we can choose to use either an open dot or a parentheses. For these examples, I'm just going to be using the open dot versus the closed dot. Okay, so then that's our answer for number 1. Looking at number 2, again, the only number we're putting on this number line is the number here, 7/3. This inequality said c is greater than or equal to 7/3. Greater than tells us we are going to the right. That greater than or equal to tells us it's a closed dot. Means it will include the number 7/3. Okay, now looking at number 3, notice that our inequality is backwards. Our variable is now showing on the right side versus the left side. Whenever we are graphing these, it's always easier to have our variable come first. So what I'm going to do is I'm going to rewrite this where I have y on the left and 3 on the right. In order to determine how I'm positioning that inequality, I look at where that inequality is pointing. So notice that it is pointing towards the y. So that means when I rewrite this, it still has to be pointing towards our y. Okay? So it looks like I changed the inequality, but I didn't. It's exactly how it was written, just reversed above. So we are now looking at y is less than 3. So here's my number line. Here's 3. Less than means all the smaller numbers, so we're going to go to the left. And since it's just less than and not less than or equal to, this is a open dot. Okay. Example 4, we have y is less than 0. So 0 goes on the number line. Y is less than, that tells us we are going to the left. And since it's just less than, this is an open dot. Number 5, draw my number line, place my number, so in this case -5/4. And then this is saying x is greater than or equal to. So greater than tells us we're going to the right. That equal to tells us it's going to be a closed dot. And then lastly on number 6, notice that our variable is on the wrong side. So I'm going to arrange this where my a variable is now on the correct side. Notice that my inequality is pointing towards the a, so I need to make sure that it continues to point towards the a. So I now have a is less than or equal to 5. I draw my number line, plot my number 5. Less than tells me I'm going to the left. Equal to tells me that is a closed dot. So when viewing these examples, notice how the inequalities, so for example, these less thans right here, okay, notice how they are all pointing to the right side. That's why we drew our arrow to the right side. Okay. Now let's notice all our less than symbols. The less than symbols are pointing to the left side. That means our arrows are also going to continue to point to the left side. Okay. Just something to keep in mind. Okay, so now that we looked at linear inequalities, let's look at compound inequalities. Okay, so compound inequalities is a statement that involves more than one inequality. So in these cases, we typically have our variable situated in between two inequalities. So looking at number 7, we have -4.1 is less than y, less than or equal to -1.7. So I'm going to go ahead and draw my number line. I'm going to bring these numbers down. So -4.1, -1.7. And I'm going to treat these as two separate inequalities. So let's first do the first inequality, which is right here. That -4.1 less than y. We know the first thing we have to do is make sure the y is on the correct side. Notice here that instead of the arrow pointing towards the y, it is pointing towards that -4.1. So I need to make sure that that stays consistent. So here I have y is greater than -4.1. So that tells me it is going to go in this direction. Okay. Now we're going to look at our second inequality. So this y is less than or equal to -1.7. So since it says less than or equal to, we are going to go in the other direction, so to the left. Okay. Notice that there's an area on this graph that overlaps. That area right here is our answer. So this area right here that overlaps. The only thing that we need to do is we need to make sure we have the correct open dot and the correct closed dot in the right places. So if I was to redraw this number line with the numbers, I know my answer would be in between these two numbers with an open dot above the -4.1 because it was greater than, and then a closed dot above -1.7 because it was less than or equal to. So this right here is the answer. Okay. So now let's look at number 8. And I know number 8 looks very similar to number 7. I'm going to actually change that up. So what I'm going to do is I'm going to change these inequality symbols so they are both greater than or equal to. So again, I'm just changing up this problem so we can see two different ways of how these graphs can look. Okay, so we're going to do the same thing, draw our number line, place our 0, place our 8.5, and then we're going to treat these as two separate inequalities. So the first inequality here, we have 0 is greater than or equal to y. Remember, we want that y to be first. So this is actually y is less than or equal to 0 because of that symbol pointing in the direction of the y. Okay. So if I was to draw that y less than or equal to 0, that means that this line is going to go in the left direction. Now, looking at the other side, y is greater than or equal to 8.5. This arrow is going to go into the right direction. Notice how these arrows look different than number 7. In number 7, they overlapped. In this one, they're going in opposite directions. Okay? So the only thing we would have to determine here is whether these are closed dots or open dots. Since they both have the equal sign, we know that they're both going to be closed dots. So closed dots above our numbers, and they are moving away from each other, and that would be our answer. So writing a quick note over here is that if we have a less than or a less than or equal to symbol, that means your answers are going to meet in the middle. So if I have a diagram here with a number and another number, my answer will always meet in the middle. If we have greater than or greater than and equal to, they're going to go in separate directions. So separate directions. Okay, so if I had my number line with my pretend numbers here, I would have one line going to the right and one line going to the left. Okay, so this is just a little note and a reference for you to use later. So that's concept 1. Let's go ahead and go through concept 2. Concept 2 talks about set builder notation and interval notation. So there are two methods to define inequalities: set builder notation and interval notation. To determine the difference between the two, we're going to use the example x is greater than or equal to 2. So we're going to use this example here. In set builder notation, the way we would write that is we would write that with this curly bracket, which means the set of x, because that's the variable we're dealing with, so all of x, that vertical line such that, and then whatever is our question asking for. So x is greater than or equal to 2. That part right here. So this part doesn't take really any work. All we're doing is we are taking the statement of x is greater than or equal to 2, and we are putting it in that notation form. For interval notation, we're going to have to draw a graph to visualize how this notation is going to work. So in this example, they have the graph here. In this case, they're using the brackets versus the parentheses. And the reason for that is because we'll be using the brackets or parentheses in the interval notation. So it's easier to see that visual if we just keep it on the graph as well. So since it was x is greater than or equal to 2, that's how they got that bracket and then greater than. Okay? When we write that in interval notation, we have a bracket around the 2, and then since it's greater than, it's going to go towards infinity. And the part that we put after infinity is always going to be that parenthesis, because that parenthesis tells us that we cannot include infinity, okay? We can never stop it. So since we can never find an ending point to that infinity, same with negative infinity, we have to close those ends with a parenthesis, not a bracket, okay? Then if you want, you could read more about that here. And this talks about the parentheses, the brackets, when to use them, when not to use them, and some cases right here. Okay, this is everything that we already covered in the discussion above. Okay, so looking at these examples, for these 6 examples, it wants us to first graph it, then put it in set builder notation, then in interval notation. Okay, so that's what we're going to do. So for number 1, we have x is less than negative 3. So I'm going to graph that first. So my graph, here's my negative 3. Less than, that means I'm going to the left. And since it's just a less than, that means I'm going to be using a parenthesis. Okay, so for these ones, since we are putting it in interval notation, make sure you are using parentheses or brackets, whichever relates to the problem. Okay, now that we have that done, we can look at the set builder notation for x is less than negative 3. So we're going to do curly bracket x, because that's the variable, such that x is less than negative 3 curly bracket. Notice the only thing that I added to the example, was the curly brackets and that x right here that's telling us, hey, we're dealing in terms of variable x. And then lastly, interval notation. Notice when we look at the number line, we need to read this from left to right. So all the way on the left side, it's going to go all the way to negative infinity. So that's how I know that's my first number, negative infinity. Okay? And it's going to stop at negative 3. Since that negative 3 had a less than symbol with a parenthesis, I know a parenthesis is going to go after that. And since we can't stop that negative infinity, another parenthesis is going to go on that side. So that is how we would set up set builder notation versus interval notation for example 1. Okay, let's look at example 2. We have x is greater than or equal to negative 1/2. Here's my line. Here's my negative 1/2. Greater than or equal to says I'm going to go in the right direction with a closed bracket. Set builder notation, I have curly bracket x such that x is greater than or equal to negative 1/2. And then looking at my graph for interval notation, I have a bracket right over my negative 1/2, and it's going towards infinity, which I can never stop, so it's a parenthesis. So bracket, negative 1/2, comma, infinity, parenthesis. Okay. For number 3, notice we have a compound inequality that is using less than symbols. Since it is using less than symbols, we know that if we write these numbers on the number line, negative 2 and 4, that our lines are going to be in the middle. And since we have less than or equal to, that is a bracket, and less than, that is a parenthesis. So skipping over to interval notation, we know that this is going to be bracket, negative 2, 4, parenthesis, following the graph. And then going back into set builder notation, we would just write y such that, because y is now our variable given, negative 2 is less than or equal to y, less than 4, curly bracket. Okay, let's look at number 4. We have x is greater than or equal to negative 2, so here's my negative 2, greater than, equal to means we go to the right with a bracket. So if I go into interval notation, I have -2 to infinity with a parenthesis. Set builder notation, I have curly bracket x such that x is greater than or equal to -2. Just rewriting my problem in there. Okay, number 5, draw my graph. Place my number 3/2. X is less than 3/2, so I'm going to go in the left direction. And I'm going to use a parenthesis since it does not have an equal sign. So then writing my interval notation, reading this from left to right, notice the left side has that arrow, so that indicates -infinity to 3/2 with another parenthesis. Yep, note these are parentheses because we did not have that equal sign in there. And then our set builder notation, we have x such that x is less than 3/2. Okay, last example for concept 2. We have, again, a compound inequality using only less than symbols, meaning our numbers are going to be in between. So -3 and 1, we know it's going to be in between. The first symbol is less than, so that is a parenthesis. And our last symbol is a less than or equal to, so that is a bracket. So we have parenthesis -3, comma 1, bracket for our interval notation. Then I do my set builder, so x such that -3 less than x less than or equal to 1. Okay, so that concludes concept 2. Okay, now let's look at concept 3. We're talking about the properties of adding and subtracting inequalities. So all this diagram is saying here is that by adding the same number to both sides of the inequality, it is not going to change that inequality. Same with subtracting the same number from both sides of the inequality is not going to change it either. So the reason they mention these is because if we need to solve for a variable, so get a variable by itself, then we are able to use those properties of addition and subtraction to do so without changing the inequality. So let's go ahead and do that in example 1. So in example 1, we have -2p plus 5 less than -3p plus 6. So what we need to do is we need to get our variables to the left side, so in this case the p's, and then everything else to the right side. So we could have the inequality p less than something. So in order to do that, we're first going to add 3p to the other side. That gives us -2p plus 3p, which is 1p, but we would just write that as p. Then I'm going to bring down all my other numbers, so plus 5 less than 6. Okay. Now I need to get the p by itself, so I'm going to subtract 5. So I have p is less than 1. Okay, and that is my answer. Now if we were to graph this, we're only graphing the answer part. So p less than 1 means I write 1 on my graph. Less than means I'm going to the left. Okay? And since it's just less than and not less than or equal to, it's going to be a parenthesis. Okay? We can also check our work to see if we did it correctly. In order to check our work, we need to follow that inequality we just found. So p less than 1 means we have to pick a number less than 1 to test within our original problem. So a number less than 1 could be 0. So let's go ahead and plug 0 in for p in our original problem. So I have negative 2 times 0 plus 5 is less than negative 3 times 0 plus 6. Anything times 0 is 0, so it cancels out. And I am left with 5 is less than 6. This is a true statement. Since it is a true statement, that means that everything that we just did before is correct. So we did get the correct inequality. Taking that inequality and putting it in set builder notation, when you put it in set builder notation, we do not want to write the large problem. We just want to write the answer to our problem. So then we would be writing curly bracket P such that P is less than 1 curly bracket. And then lastly, interval notation, looking at our graph, we have negative infinity, comma 1, with both of them having parentheses. Okay, now let's look at example 2. Example 2, we have 2y minus 5 is less than y minus 11. We need to get all our y's to the left side. So first, we're going to subtract y over to the left. That gives us 2y minus y, which is just y, minus 5 is less than negative 11. I brought all the other numbers down. Now I'm going to add 5 to both sides, and I get y is less than negative 6. Drawing my graph, I plot my negative 6. And then I have y is less than, so I'm going to go to the left. And since it's just less than, it's going to be a parenthesis. Okay. Now to check if this is correct. So we need to pick a number that is less than negative 6. Since we're dealing with the negatives, remember as our negative number gets larger, for example, negative 7, negative 8, those numbers are actually getting closer to negative infinity, so they are actually getting smaller. So let's go ahead and pick negative 7. So I have 2 times negative 7 minus 5 is less than negative 7 minus 11. 2 times negative 7 is negative 14. Bring down that minus 5, bring down that less than, and negative 7 and negative 11, when we add those together, gives us negative 18. So then we are left with negative 19 is less than negative 18, which is a true statement, which infers that we did all the math correctly. Okay, so putting this in set builder notation, we have curly bracket y such that y is less than negative 6. And then for the interval notation, we have negative infinity, comma negative 6. Again, both with just parentheses. Okay. Concept 4 is multiplication and division property of inequalities. So what this diagram is saying here is that if we have a positive value that we are multiplying or dividing either side of the inequality, then the inequality is going to stay the same. If we multiply or divide by a negative number, then our inequality is going to flip. So if we have a less than, that is going to turn to a greater than, so on and so forth. So let's look at some of these examples. Example 1, we have negative 5x minus 3 is less than or equal to 12. Here, all they want us to do is just get our variable by itself. So first thing I'm going to do is add 3 to the other side, and I get negative 5x is less than or equal to 15. Divide by negative 5, and I get x is greater than or equal to negative 3. Because I divided by that negative number, my inequality sign flipped. Okay, and this is my answer. Okay, now let's look at number 2. Number 2, we have negative 5p plus 2 is greater than 22. So I'm going to subtract 2 to the other side, and I get negative 5p is greater than 20. Divide both sides by that negative 5, which means our symbol is going to flip. So then I have p is less than negative 4. Okay, number 3, we have a lot of different things going on here. So before we can start moving things to either side of the inequality, we're going to have to do some simplifying. So remember, if you see a number outside of a parenthesis, so for example this, we have to distribute that number inside. And what I mean by distribute means multiply. So we're going to go ahead and do that first. So I'm going to bring down that 12. Negative 2 times y is negative 2y. Negative 2 times 3 is negative 6, less than. Negative 3 times 2y is negative 6y. Negative 3 times negative 1 is 3. Bring down that 2y. So all I did here was get rid of my parentheses by distributing that number in. Now what I'm going to do is start simplifying and combining like terms. So on the left side, I have 12 minus 6, which is 6, and then I'm going to bring down that negative 2y. And then on the right side, I have negative 6y and a positive 2y, which gives me negative 4y, and then bring down the 3. Now that both of my sides are simplified, I can start bringing over my y's to the left side. So plus 4y. So I get 6 plus 2y is less than 3. Subtract the 6 to the other side, and I get 2y is less than negative 3. Divide both sides by 2, and I get y is less than negative 3 halves. Notice that since I was dividing by a positive number, my inequality symbol stayed the same. Now let's look at number 4. So number 4 is very similar. First, I'm going to distribute these numbers outside of the parentheses. So bringing everything else down, I have negative 8 times 2x, which is negative 16x, and negative 8 times negative 4, which is a positive 32. And then negative 5 times 4x, negative 20x. Negative 5 times negative 5, positive 25. Bring down that negative 21. Okay, now I gotta see if I can simplify both sides before I start bringing things over. So on the one side I have negative 8 and a positive 32. If I add those together, I get 24. Bring down that negative 16x. On the other side, I have 21, that negative 21 and a positive 25. Add those together and I get 4. So I have negative 20x plus 4. Now I want to bring all my x's to the left side, so I'm going to add 20x. And so I have 24 plus 4x is greater than 4. And I'm going to subtract 24. And I get 4x is greater than negative 20. Divide by 4, and I get x is greater than negative 5. Again, since I divided by a positive number, my inequality did not change. Okay, now let's look at 5. Notice in 5, we have a bunch of fractions here. To me, the easiest way is just to get rid of those fractions right off the bat. And in order to do that, we can multiply the entire problem by a common denominator. So here we are dealing with the denominators 4, 6, and 3. So a common denominator for all 3 of those would be the number 12. So I'm going to multiply this entire equation by 12. So I'm going to distribute this 12 inside. And I'll go ahead and write out all the steps so you can see what's happening. So for the first one, I have 12 over 1 times negative 1/4 k plus 12 over 1 times 1/6 less than or equal to 12 times 2 plus 12 over 1 times 2 over 3k. Notice that when I was multiplying a number by the fraction, I turned that whole number into a fraction by writing it over 1. That's going to help us when we are multiplying these across and getting rid of the fractions. So doing that, we have negative 12 over 4k plus 12 over 6 is less than 24 plus 24 over 3k. Simplifying these, we get negative 3k plus 2 is less than or equal to 24 plus 8k. Now we have everything simplified without the fractions, so I can go ahead and start moving things around. So I subtract the 8k here, and I get negative 11k plus 2 is less than or equal to 24. Subtract 2, and I get negative 11k less than or equal to 22. Divide by negative 11, which is going to flip my sign, and I get k is greater than or equal to negative 2. Okay, so we're going to do the same thing for number 6. Notice that I have the denominator 5 and 2. So a common denominator between both of them is 10. So I'm going to multiply this entire problem by 10. So doing the exact same thing. So I have 10 over 1 times 1 over 5t plus 10 times 7 less than or equal to 10 over 1 times 1/2 t minus 2 times 10. This gives me 10 over 5t plus 70 is less than or equal to 10 over 2t minus 20, which simplifies to 2t plus 70 less than or equal to 5t minus 20. Now I can get the t's on the same side by subtracting 5t over. And I get negative 3t plus 70 less than or equal to negative 20. Subtract 70 to the other side, and I get negative 3t is less than or equal to negative 90. Divide both sides by that negative number, which is going to make the symbol flip. And I have t is greater than or equal to 30. Okay, and then that concludes concept 4. Looking at concept 5, we have the inequalities of form A less than x less than b. All this is saying is that now instead of having our x value, our variable, being moved all the way to the left, that variable is going to stay in the middle. So whatever we do to get that variable by itself, we have to do to both the right side and the left side. So for this one, we're first going to subtract 1 from every side. Okay. Doing that, we get negative 4 is less than or equal to 2x less than 6. Then divide everything by 2. And we get negative 2 is less than or equal to x less than 3. So this is our answer here. Notice since I did not divide or multiply by a negative number, my symbols stayed the same. Okay, now let's look at example 2. I'm going to add 5 to all the sides. So I get 2 is less than or equal to 2y less than 16. Divide everything by 2, and I get 1 is less than or equal to y less than 8. Again, that is my answer. Since I did not multiply or divide by any negative numbers, my symbols stayed the same. Okay, then I believe this is the last concept, concept 6, which is applications of linear inequalities. Remember, when you see the word applications, that means word problems. When we are viewing these word problems, they are going to use phrases that we need to interpret as a mathematical inequality. So for example, if they say A is less than B, then we know that we're using the less than symbol. If we see A is no more than B, we are using the less than or equal symbol, so on and so forth. So this is good information to have. Okay, so for number 1, it says Claude's annual salary S is no more than 40,000. So we can look back at our chart. No more than is less than or equal to. So we would write S less than or equal to 40,000. And that's our answer. Number 2 says a citizen must be at least 18 years old to vote. Let A represent a citizen's age. So at least, if we look at our chart, at least means greater than or equal to. So A greater than or equal to 18. Number 3 says an amusement park ride has a height requirement between 48 inches and 70 inches. Let H represent height in inches. Okay, so remember, if we see the word between, we're using less than symbols. When we are talking about the height for a ride, this means that we could be 48 inches and we could be 70 inches. So this would be 48 less than or equal to H, less than or equal to 70. Okay, number 4, it says Bill needs a score of at least 92 on the final exam. Let X represent Bill's score. So at least is greater than or equal to, so X greater than or equal to 92. Number 5 says fewer than 19 cars are in the parking lot. Let C represent the number of cars. Fewer than would be less than 19. So C less than 19. Number 6, the heights, age of a woman who wear petite size clothing are typically between 58 inches and 63 inches inclusive. Inclusive tells us that we can include those heights, and that between tells us that we are using less than symbols. So we have 58 less than or equal to H, less than or equal to 63. So notice in example 1 through 6, all we had to do was set up the problem. In the last 2 examples, not only are we setting up the problem, we're going to have to solve. So looking at number 7, it says to earn an A in math class, Ashley must average at least 90 on all her tests. So average at least. Remember, at least means greater than or equal to. So let's label her tests greater than or equal to 90. Suppose she scored a 79, an 86, a 93, a 90, and a 95 on her first 5 tests. What is the minimum score she needs on her test to get an A? So since we're finding the average, we're going to add these all together. So 79 plus 86 plus 93 plus 90 plus 95 plus that 6 test T, okay, all divided by 6 to find that average is going to have to be greater than or equal to 90. So let's go ahead and add all those numbers together. So I have 79 plus 86 plus 93 plus 90 plus 95. That gives me 443 plus T over 6 greater than or equal to 90. Now I'm going to multiply both sides by 6, and I get 443 plus T is greater than or equal to 540. And then I'm going to subtract that 433 from that 540, and I get t is greater than or equal to 97. So this tells us that in order for her to get an A in the class, she needs at least a 97 on her test. Okay. Number 8, very similar, different numbers. This time they said in order to earn a B, they need to have an average of at least 80. So t greater than or equal to 80. Our test scores this time are 60 plus 72 plus 98 plus 85 plus t. This case, there is only 5 tests, so this is being divisible by 5. So let's go ahead and simplify those numbers. So 60 plus 72 plus 98 plus 84 gives us 314 plus t over 5 greater than or equal to 80. Multiply both sides by 5, and we get 314 plus t greater than or equal to 400. And then subtract that 314 over, and we get t is greater than or equal to 86. So in order for this student, Simon, to get at least a B on all his tests, he needs to score at least an 86 on his last test. Okay, that concludes the notes for 10.8. If you have any questions, please feel free to let me know.